Hey, what's up, guys? Welcome back to A Math Lab. Today we're going to be going over x and y intercepts. Okay. Let's say you have 2x plus 5y is equal to 12. Okay. Let's say you want to find one of the intercepts. If you want to find the x-intercept or the y-intercept, doesn't really matter. If we're trying to find the y-intercept, it's a point at which a line is going to pass through the y-axis here. This is x, this is y, and this is x. So we want to find when x is equal to 0, because at this point right here, x is equal to 0, right? So at this point, there must be a y-intercept of a line if a line passes through this point. So let's see. That means that if we want to find a y-intercept, for example, we have to set x equal to 0. So the first step is set x equal to 0. And that's to find, write that, find y-intercept. Okay? If we set x equal to 0 here, well then all we're going to do is say 2 times 0. We replace the x with 0, and we don't do anything with the y. Just keep it as is. Okay? 2 times 0 is 0. 0 plus 5y is equal to 12. And then what we're going to do is divide both sides by 5. Because all we're doing at this point is solving for y. So y is equal to 12 over 5. Yeah, looks good. Well, okay, whatever. I gotta get better at this filming thing. Okay, so that's our y-intercept. That means that at 12 over 5, which is really like 2 2/5. So at y is equal to 2 2/5, you have, here's 2 2/5, which is like right here. There's a y-intercept. So there's a line, who knows where it passes. I don't really know, it could be any kind of line. But it passes through 12/5. So that's the basic idea. Now let's say we want to find the x-intercept. Not a problem. On our graph, if we're going to try to find an x-intercept, that means that a line's going to pass through somewhere along the x-axis. So at this point, y is equal to 0. So wherever it's passing through, y is going to be equal to 0, because y is equal to 0, right? Well, anywhere along this line, y is equal to 0. Okay? So, let's see. If we want to find the x-intercept, the x-intercept, now we're going to have to set y equal to 0. So we do the opposite. Okay, so now 2x plus 5 times 0 is equal to 12. Well, 5 times 0 is 0. And we have 2x is equal to 12. And then here we're going to actually divide by 2. Divide that by 2 as well. And we have, these cancel out, x is equal to 6. So on our graph, at x is equal to 6, 1, 2, 3, 4, 5, 6, there's going to be a line passing through there. We don't know the specifics about the line just yet, unless we plotted some numbers. Then we would know exactly what's going to happen. But actually in this case, it's just going to be a straight line, since this is a linear function here. And it's the same thing here. If we were to say, let's say we were to find the x-intercepts here at y is equal to x squared plus 4x plus 4. This is actually going to just factor out as x plus 2 squared. Okay, so it's just saying x plus 2 x plus 2. X plus 2 two times, we set this equal to 0. And if we set, actually in this case, we're just setting y equal to 0, right? The same thing as we did before. We'll find out we actually have x plus 2 two times, don't we? So if we set x plus 2 equal to 0, then we're going to get minus 2 on both sides. X is equal to negative 2. So it's the same thing with quadratic formulas. You still set y equal to 0. I'll probably make another video with some more complicated ones. So, but that's the basic idea. If you're finding the x-intercept, set y equal to 0. If you're finding the y-intercept, set x equal to 0. Either for linear or quadratic equations. And later on in math, you get a little more complicated, and you need to use different kinds of tools like the quadratic or completing the square, things like that. So, I hope this was helpful for you. I'll probably do another one just like this, but maybe, I don't know, using quadratic formula or something. Alright, thanks!